Greetings, hello and welcome back to another Math 104 lecture. So in the previous lecture, what we were doing was we were looking at absolute values, and what we determined was we can solve absolute values inside of equations as long as we kind of look at two different cases, right? One where the side that wasn't in the absolute value was positive, and then one where that same side was negative. You would occasionally come across where you had just a linear equation inside of an absolute value as part of an equation, but that would still yield two separate solutions. So it was almost like you were solving two different linear equations, right, based on the case. And when you did plug into your absolute value, you would find that, oh yeah, both solutions worked. So yes, there could be two solutions to a linear equation, even though it would be just part of an absolute value. So today what we're going to be looking at is we're going to be looking at what happens if we examine inequalities with absolute values. So let's take, for example, if we just have absolute value of x is equal to 3. So we're going to start with the equal sign first. And as we learned, there's going to be two solutions to this, right? Because we know that 3, when plugged in for x, will make this true, but also -3 would make this true, right? So we know that the solution set for this is 3 and -3, right? Okay, so there's by trichotomy, and trichotomy is that word that came up before, and just to do a quick review, trichotomy means that if you pick any two numbers, any two real numbers, doesn't matter what they are, right, and we say A and B, that one of the three statements is going to be true, right? Either A equals B, A is less than B, or A is greater than B, right? Well, going back here, we just showed that the absolute value of x equals 3. There's two solutions, right? So if this is your B and this is your A, then 3 and -3 would fill in for this one, right? If you plugged in 3 or -3 for x. But what about any other number? What happens if we plugged in -4 or 4 or -5 or 5 or so on and so forth, right? Well, that means that by trichotomy, it can't be this one because we just solved for that one. That's 3, -3. So by trichotomy, it's either going to be less than 3 or greater than 3. And it's kind of up to us to figure out how we do that, right? So by trichotomy, we know that inequalities are still going to hold for absolute values. It's just a little bit different on as far as how to find them, right? So once again, we're going to start with absolute value of x on one side, and we're going to start with 3 on the other. And the first case that we're going to be looking at is absolute value of x is less than 3. So what does it mean for an absolute value of an unknown to be less than some other number? Well, if you think about it, if you were to analyze it the same way that we did with an equation, you broke it up into cases. The way that we would think about it is, okay, well, it's going to be one of two things, right? We're going to keep x the same, right? We drop the absolute value and we keep the other side the same as 3. But what is really going on here? Okay, so this means that if you plugged in 4, for example, this wouldn't be true, right? And so if we plugged in 4 for x, we would get 4 is less than 3, and that's not true. And the same thing if you plug in 4 is inside the absolute value. The absolute value of 4 is still just 4, and that would still also not be true. So as we can see, as the numbers get larger and larger for the positive values, it's still going to make sense even without the absolute value sign, right? So if we plugged in, again, I'm just going to do hypothetically, if we plugged in 4 here, well, the absolute value of 4 is still just 4 once again, and 4 less than 3, well, this doesn't work, right? This is false. But we can look at all the numbers that are less than 3. So why don't we start going through a couple, right? Let's say we plug in, I'm going to make a table of a couple numbers, and on the left-hand side of this table, I'm just going to say whether it's true or false, right? Whether it's, works in the inequality or whether it doesn't work in the inequality. So making our table for absolute value of x is less than 3, we just saw that, 4 and going upwards doesn't work, right? So this is going to be false, which means all the numbers that are greater than 3 would not work for this. And again, that's pretty intuitive, right? Because again, absolute value of that number is still just going to make it positive. Well, okay, what if we plug in 3? Well, plugging in 3, remember, this is strictly less than, right? So if we're talking about, oops, sorry, my tablet wasn't scrolling. So this is strictly less than here, right? If it were less than or equal to, then yeah, 3 would be true. But because it's strictly less than, we would put a false. And then why don't we try 2? Well, trying 2 we know that 2 will work, right? Because if we plug in 2 for x, we get the absolute value of 2. That's still just 2. 2 is less than 3, right? And you can keep extrapolating, right? And you know that it's going to start being true as soon as it's less than 3. But is it always going to stay true? Well, we're going to see. Let's skip a couple numbers because, again, you can go through them and you can see that it's going to make sense, right? 2, 1, 0, -1, -2. That's all correct, right? What about -3? Well, at -3, so I'm putting a couple dots here. So at -3, it's going to be false again. Why is it going to be false? Well, at -3, we see that it's the absolute value of -3, and the absolute value of -3 is 3, and 3 is not less than 3, right? So we see that it's in fact false here. And we keep going, -4. Well, plugging in -4, we get the same result as plugging in 4. Plugging in -5, we get the same result as plugging in 5, right? And then it just continues to get false, 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 right? And it stays false. So what we're really saying here is that there's only a certain interval in which this is going to be true. It's going to be false for all the numbers that are larger than 3, and it's going to also be false for all of the numbers that are less than -3, right? You see how -3 is our breakpoint? This is where it starts being false again. If we plugged in -2.999, we would have the absolute value of -2.999. And then, well, this gives us 2.999, and 2.999 is in fact less than 3, right? So we can get really super close to -3, but as soon as we hit -3, it stops being true. And then the case may be for all of the negative numbers that are less than -3, that it's going to remain false. So we see that there's actually only a specific interval of values where this remains true. Okay, well, how do we put this in terms of math? Like, how do we use mathematical notation to show this? Well, keep in mind that the breakpoint, this started being false at 3, and it started being false at -3, right? So your breakpoint here is at the number here and at the negative version of that number. So we can create a compound inequality and say, okay, so what this is telling us right here is this is telling us that we have the compound inequality from -3. We keep whatever sign that we had. So in this case, it was a less than. So -3 is less than x is less than 3. So what is this telling us? This is telling us that the only intervals that this work is between -3 to 3. And if we're plotting this on a number line from -3 here, 3 here, 0 in the middle, right? We would put open circles here because we're not including those endpoints. And the only interval that works is going to be the interval between the pieces, right? From -3 to 3. So again, what this up here is saying is that, okay, this works for a lot of the numbers that are less than 3, but eventually it'll stop working because the size of the negative numbers will continue to grow. And remember what absolute value is doing. It's taking the size of the number. It's taking the distance away from 0. So -4 is 4 steps away from 0, which is why we get a +4. And 4 is not less than 3, right? So hence it stops working. So as we can see again, it stops working at the negative version of that number. So let's extrapolate a little bit and generalize it. So instead of a 3, what we can say is if we have absolute value of something, some unknown, it doesn't have to be x, it just has to be something inside the absolute value, is less than some number, I'm going to call it a, we will always end up with this compound inequality from -a to whatever was inside your absolute value to a. And also, we can go ahead and this would work for less than or equal to as well. So I'm going to just do this in green because you might not always have a less than or equal to. It could just be a less than, but you just match the sign. So if it's less than, then it remains as just less than in the compound inequality. If it's less than or equal to, that's telling you want to include your endpoints, so it remains less than or equal to. So then you would, again, your number line would look something like from -a to a, with 0 in between, right? And it would be all of these points. And the only thing that would change, again, between less than or equal to is what happens with the circles, right? If it's strictly less than, they're open circles. If it's less than or equal to, then you are including those endpoints, right? So then it would be filled in circles as well. But the main point that you should really understand here is it would only be this specific interval. It would not be the intervals beyond the 2 endpoints. Okay, so negative infinity all the way to negative a would not work, and a all the way or after a all the way to infinity would also not work. Just strictly the middle interval. Okay, so let's go ahead and do an example regarding this. Okay, so our first example that we're going to have with this is going to be the absolute value of 3x plus 3 is less than or equal to 6. Okay, well, we already talked about this, right? And I said whatever was inside your absolute value doesn't strictly have to be x. It could be some operations tied to your unknown, right? So in this case, we see that x is being multiplied by 3. We also see that it's being added 3, right? Well, the most important and the most critical part of this is you understand that because it is less than this number here, and yes, I see that it's less than or equal to, but again, just think less than, right? Because it's less than, we know we're going to have a compound inequality with the number that we're starting with on the right and the negative version of our number on the left. And whatever sign we have, we keep the sign the same. So in this case, less than or equal to, and whatever our absolute value is going to be the middle piece. So 3x plus 3 inside the middle. Well, we know how to solve this. We already talked about compound inequalities when we were talking about inequalities 2 lectures ago. So how do we solve this? Well, essentially, you're just solving for x. And that means that whatever operations you do to the middle, you're also doing to the outsides, right? So we're just going to subtract 3 from everywhere. So subtracting 3, we get negative 9 over here. We get 3 over here. And we have 3x. And now to isolate for x, we're going to divide everywhere by 3. So we get negative 3 is less than or equal to x is less than or equal to 1. And now we finally have x by itself, and we have an interval of values. And putting it in interval notation, this means we're going to have from negative 3 to 1, and we are including the endpoints because it's less than or equal to, so we would put brackets, right? So this would be our solution interval to the original right up here of the absolute value of 3x plus 3 less than or equal to 6. And plotting this on a number line one more time just to really hammer this down, we see that it's from negative 3 to 1, and 0 is going to be in between, right? I'm just putting the 0 as a reference marker. So 0 is in between. We know it's going to be all of the numbers between negative 3 and 1. And we're just going to have closed in circles because we're including the endpoints. Now notice, if you wanted to test this, pick any number between negative 3 and 1. If you pick 0, for example, if we had 0, just to do a quick test, 0 would be the absolute value of 3 times 0 plus 3 less than or equal to 6. Well, 3 times 0 is going to give you 0 plus 3. We get the absolute value of 3 is less than or equal to 6. And we know that that's just going to be 3 is less than or equal to 6. And yes, that is in fact correct, right? 3 is less than or equal to 6. Well, let's see if we pick a number outside of the interval. Let's see if we'll have the same results. So a number that's outside the interval is going to be 2, right? Say I pick 2. So picking 2, we are just going to, I'm just going to erase things because it's a lot easier to do that than write it all over. So 3 times 2, well, 3 times 2 is going to be 6, plus 3 is going to be 9. So we have the absolute value of 9, and the absolute value of 9 less than or equal to 6 is incorrect, right? That does not work. So as you guys can see, we are very much constricted by the interval that we have constructed. And the interval that we have constructed is very much based around this compound inequality right here. And that is, again, derived from our understanding that it's going to work for the numbers less than the positive value, but it's not going to keep working, right? So, as we can see, it works for 1 because we're including the endpoint. And then it works for a half, it works for 0, it works for negative 1, all the way up until negative 3, but then it stops working after negative 3. If we, tested negative 4, for example, it would not work. So our only interval of values is from negative 3 to 1, including the endpoints. Okay, let's do one more example together, and then I'll put you guys onto your classwork assignment. I'm not going to talk through this one as much. Hopefully you guys understand the gist of it. So now what we're going to have is the absolute value of 4x minus 1 is less than or equal to 9. And what I want is, again, I want to get my interval in, I want my final answer to be in the interval notation, and I want to graph this. So let's go ahead and work through this. Once again, we see that we have the absolute value is less than a number, right? So what we have to do is we have to set it up as a compound inequality. And we start with the number that we're given on the right-hand side and the negative version of that number on the left side. So less than, and whatever sign we have, we just repeat the sign, and we put in 4x minus 1. Okay, so now all we have to do is, once again, we just isolate for our x. So isolating for our x, we have add 1 to both sides. Adding 1 to a -9 is going to reduce that negative number, so we're back to -8. And 4x in the middle, and adding 1 to 9 is going to give us 10. Dividing 4 on both sides, we have -8 divided by 4, which leaves us with a -2, is less than or equal to x. We have finally isolated x. And 10 divided by 4, I'm just going to simplify that fraction to be 5/2. So we are left with -2 is less than or equal to x is less than or equal to 5/2. So this tells us our final interval, we're doing brackets because once again, it's a less than or equal to, is -2 to 5/2. And if you really wanted to, because again, you might not know what 5/2 is without actually doing the division or plugging it on a calculator, it's okay to say, well, 5/2 is really 2.5. So this is one of the few instances that I say a decimal is going to be okay. I know that I said in the beginning of the semester that try to stay away from decimals. This is kind of the only instance where I say it's okay, because if you're plotting it on a number line, you might not know where 5/2 exactly falls. Personally, again, with practice, you might be able to just figure that out. But if you need to write 2.5, you need to write 2.5, and that's okay. I'm just going to leave it as 5/2 because I know it's 2.5. So -2 to 5/2. And we're going to plot this on our number line. We put -2 here, we put 5/2 here, and we know from -2 to 5/2, this entire interval is going to work. So we shade in this region. We know that because we're including the endpoints, we fill in our circles, right? So it's that easy. So once again, the idea is when you have an absolute value that's less than or equal to a number, you put it in a compound inequality where whatever is inside your absolute value goes to the middle of your compound inequality. Your number stays the same on the right-hand side, and you get the negative version of your number on the left-hand side. And remember, this is all because of what we talked about of how these inequalities will stop working after a certain point, and that break point is always at the negative version of that number. So the negative version, in this case, of 9. Okay, so that's it for that class, for that example. I want you guys to go ahead and try your first classwork assignment. And your first classwork assignment is as follows. It is the absolute value of 4x minus 6 is, less than or equal to. I know I've done 3 examples in a row with less than or equal to, but it's the same process as it would be with less than. It's just that you just wouldn't fill in your circles, your endpoints. So 4x minus 6 is less than or equal to 6. Go ahead and give this a shot. See if you guys understand the process so far. Okay, so the entire idea here, once again, is, well, we're going to keep our signs the same. So less than or equal to, less than or equal to. We know that the middle piece is going to be whatever was inside our absolute value, so 4x minus 6. And we know that our endpoints, the points where this interval will work, is starting from the number, right? The same number that we were given on the greater side, and on the leastmost side, it's going to be the negative version of that number, so -6. Okay, so all we have left to do is just solve for x, right? So whatever we do to the inside, we do to the outside pieces. We're going to isolate x, and that means adding 6 to both sides first, right? So adding 6 to the right-hand side, we get 12. Adding 6 to the middle, we get 4x. And adding 6 to the left, well, -6 plus 6 gives us 0. Okay, and now all we have to do is isolate x. So just divide by 4, right? We have 4 times x, so undo multiplication, divide by 4. 0 divided by 4, well, 0 divided by anything is just 0. So we keep 0. Okay, 4x divided by 4 is just x, which is exactly what we want. And 12 divided by 4 gives us 3. So we now have our interval for our solution, and we're including endpoints because it's less than or equal to. So it's from 0 to 3 with the brackets. And to graph our solution, once again, we put 0, we put 3. It's filled in circles because we are including our solutions, and it is the entire area between 0 and 3. And once again, if this doesn't make sense to you, I encourage you to check numbers that are both inside your interval that we got and outside the interval on both sides. If you wanted to try -1, you will see that -1 will not work. Same thing with 4 or 5 or so on. The only interval that's going to work is from 0 to 3, and the only reason that 0 and 3 work is because we're including the endpoints. If it was strictly less than, so if we were starting with absolute value of 4x minus 6 less than 6, not less than or equal to, then we would have parentheses for 0 and 3. We would have open circles for 0 and 3, and it would just be the numbers between 0 and 3, not including the endpoints. Okay, so that is it for absolute value being less than a number. What about absolute value being greater than a number? Well, absolute value being less than a number, we saw is, it kind of turns into a compound inequality. But what is it really? If we take our compound inequality, right, we know that, I'm just going to rewrite this. We know that this directly gives us -a is less than x is less than a, right? But a compound inequality is really just two inequalities kind of smushed together, right? This is the same thing as -a is less than x and x is less than a, right? You'd agree with me that all we're doing is we just kind of took two different inequalities and put them together by the transitive property, right? Transitive just means that, if I have a number less than a second number, less than a third number, then the first number will automatically be less than the third number, right? So that's transitive property, and that's really all we did for this compound inequality. So we just split it up just now to be two separate inequalities. Well, if we had the absolute value of x is greater than a, well, we're also going to have two different inequalities. And what we're going to see is it's basically going to be just the flipped version of these guys here. So imagine just these being flipped around. So instead of it being -a is less than x, it would be x is less than -a. Instead of it being x is less than a, it's going to be a is less than x. So we'll write it out. And once again, this basically just tells us we are going to have x is less than -a or x is greater than a. Okay, and again, this should make sense because we're just taking the two that we have and flipping them around, right? Instead of -a is less than x, we have x is less than a, -a. And instead of x is less than a, we have x is greater than a, right? All we did is we just took the things that we had and flipped them. So let's see if we can take our two new inequalities and apply them to an example. So let's say we had the absolute value of 2x minus 8 is greater than 4. Okay, so absolute value of 2x minus 8, and again, now it's greater than 4. So what we have to do is we have to take the two new things that we just solved for, right? The two things that we flipped on their head, and this is what we're going to solve. We're going to set up two different inequalities. So the first inequality that we're going to have is we're going to have 2x. So we're going to have 2x minus 8 is greater than 4. And where am I getting this from? Well, this is the first case of x is greater than a. So all we're really doing is the first case, when you have a greater than sign, is we're just removing the absolute value. It's the same inequality, right? You can see here that this inequality is the same thing as this one, just no absolute value. So the first case is exactly that. So we just drop the absolute value. We have 2x minus 8 is greater than 4. Okay, we solve for it, right? So we add 8 to both sides. We get 2x is greater than 12, and that means x is greater than 6. And putting this in interval notation, x is greater than 6. That means that we're talking about all the numbers bigger than 6, right? Starting from 6, we are going 7, 8, 9, 10, so on and so forth, all the way to infinity. So since we're starting from 6, we have 6 to infinity. We know that when we have infinity, it's always going to be a parentheses. And because its x is greater than 6, strictly greater than, right? Not greater than or equal to, it is a parentheses here as well. So this is going to be part 1 of our total solution. Now we have to do the other piece of this, which is x is less than -a. So this piece here that I just put a blue arrow to. So now we have to do x is less than negative a, and that means that we have to do everything that is inside our absolute value is less than the negative version of the number that we're given. So we have now 2x minus 8. Again, we drop the absolute value, we switch the sign, and we negate the number. So now it becomes -4. We switch it from a greater than sign to a less than sign, and it becomes -4. So now we're going to add 8 to both sides. Same exact principle, right? So adding 8, we get 2x is less than 4, right? -4 plus 8 gives us a +4. Divide by 2, we get x is less than 2. And what does this tell us? This tells us we're looking for all of the numbers that are starting from 2, but less than 2, right? So we want 0, -1, -2, so on and so forth, all the way up until -infinity. So that means we're starting from -infinity. And once again, doesn't matter the sign of the infinity, you always put a parentheses, and it goes up until 2, and we have a parentheses here as well. So putting these two pieces together, we end up with -infinity to 2, union with 6 to infinity. And now plotting this on a number line, we have, well, if 2 is here and 6 is here, we're going to have all of the numbers from -infinity all the way up until we hit 2 with an open circle. We don't include the middle interval, and we have all of the numbers after 6 going to +infinity. Well, this should look eerily like very, very similar in a way to what we just did with the, absolute value is less than. Remember, when we were doing the less than, what interval did we get? We got all of the numbers that were between our endpoints, right? So we had all of these numbers instead. Well, if we have the greater than the number, absolute value is greater than some number, notice that we got the outside intervals now. So, to the left and to the right of our endpoints. So how do they come together? Well, again, let's do a little table here to really show why this is happening. So we're going to have, we'll do our base case here. So absolute value of x, but this time is greater than 3, right? And we'll make ourselves a little table. So for x, and again, I'm going to just put true and false, right? And so let's say we have 5, 4, 3. Well, it's true for 5, right? If it's true for 5, because absolute value of 5 is still 5, 5 is greater than 3. It's true for 4, right? And then it starts being false here because we're not including our endpoint, right? We're not including 3. And then we see, well, wait, what about 2? Absolute value of 2, it's still false, right? And we can continue this extrapolation, and it goes all the way, even through some negative numbers, up until we hit -2, right? Absolute value of -2 is still 2, and is 2 greater than 3? Well, no, right? So now you guys can see that when we have the greater than sign pointing towards the absolute value, all of the numbers that are between the endpoints are going to be false, as opposed to all of the numbers between the endpoints being true when we had the less than sign pointed towards the absolute value. So when does this start being true again? Well, -3, absolute value of -3 is 3. Is 3 greater than 3? No, right? So this is still false. But at -4, this is true again, right? -4, we plug that in. -4, absolute value of it is still +4. +4 is greater than 3, so it's true. Same thing with -5, and so on and so forth, right? True, and then it remains true all the way down. Same thing with everything that's above 5, or everything that's, above 3. So everything that's beyond -3 and everything that's beyond +3 is going to make this true. Hence, that's why those two intervals on the outside of the endpoints make it true. And that's what we saw here, right? The two intervals on the outsides are going to be true. Okay, so let's go ahead and let me see. Do I have another example before the classwork? I do. Great. Okay, perfect. So let's go ahead and do one more example here. So again, another example that we're going to do is we're going to have the same numbers as your first classwork assignment. So absolute value of 4x minus 6. And we're going to this time have greater than or equal to 6. So in your classwork example that we just did, it was less than or equal to. Now we're going to have an example where it's flipped, right? Greater than or equal to. So you go through the same process. What's your process? Well, the process is your first case is just drop the absolute values, right? So your first case is you have 4x minus 6 is greater than or equal to 6. And your second case, which I'm going to write over here, is you still bring down 4x minus 6 with no absolute value, but now you flip the sign and you negate the number. So 4x minus 6 is less than or equal to negative 6. Okay, so let's solve this one first. So adding 6 to both sides, we get 4x is greater than or equal to 12. Divide by 4, we get x is greater than or equal to 3. And now on this side, we add 6 to both sides once again, right? So adding 6, we got 4x is less than or equal to 0. Divide by 4, we get 0 still. Divide by 4 is still 0. So x is less than or equal to 0. And now let's go ahead and figure out our intervals. So once again, this is all of the numbers starting from 3 that are bigger than 3. So starting from 3, including 3, bigger than 3. And this is all of the numbers that are less than 0 all the way up until we hit 0, right? So because x is less than 0, we're talking about all of the numbers that are negative, right? So from negative infinity all the way up until we hit 0, and we're including the endpoint 0, right? So we put these two together and we say, okay, well, our final interval solution is from negative infinity up until 0, unioned with 3 all the way to infinity, and we're including 3. And when we plot this on our number line, we see we have 0 here, we have 3 here. We're including the numbers once again, just like we did in your classwork. So we have those filled in. But notice how when we flip the sign, now it's all of these numbers on the outsides that made it true. And I'm going to write this in red. The piece that I'm going to draw in red here is from your classwork assignment, which was all of these guys. And now notice how the middle piece is now false for the greater than or equal to 6, but your middle piece was true for the less than or equal to 6, and the outside pieces were false for the less than or equal to 6. So as you can see, depending on which one you have, you're going to fill in parts of your number line. You're either going to have between your two numbers or you're going to have outside your two numbers. Okay, so let's go ahead and I want you guys to try a classwork assignment number 2. So classwork assignment number 2 is as follows. You have absolute value of 2x minus 3, and this is going to be greater than or equal to 6. Okay, so go ahead, give this a shot. That's an absolute value, not a 31. Give this a shot, see if you can now, see the rhythm to this. Oops. Oh, I just realized that was supposed to be greater than. My mistake. I have it right in the classwork, I promise. Okay, so barring the mistake that I just wrote, where I wrote less than, and that was on me, but it should be right in your classwork assignment. So we have 2x minus 3 inside absolute value is greater than 6, greater than or equal to 6. So our first case, once again, is we just keep everything the same, just drop the absolute value, right? So 2x minus 3 is greater than 6. And then over here, what we have is 2x minus 3, again, drop the absolute value. This time we flip the sign and we negate the number. So 2x minus 3 is less than or equal to negative 6. So now what we're going to do is we're going to solve for x. So we add 3 over here. We get 2x is greater than or equal to 9. Divide by 2. X is greater than or equal to 9. And I'll just write this as a 9 over 2. And I'll write this as a reference for you guys. 9 halves is really the same thing as 4.5, right? Just so you have an idea of where this is landing. Okay, and over here, we're going to add 3 to both sides. We get 2x is less than or equal to negative 3. And dividing by 2, we get x is less than or equal to negative 3 halves. And this is the same thing as negative 1.5. Okay, so now plotting this on our number line, what is this going to look like? And I guess before we plot it on our number line, we should figure out the interval, right? So the interval on the left is all of the numbers bigger than and including 4.5. So I'm just going to write it as 9 halves. So we have 9 halves all the way to infinity. And then on this side, we're talking about from negative infinity, because it's all the numbers that are less than this number, all the way up until we hit negative 3 halves or negative 1.5, either way. And now we're just going to union those pieces together. So negative infinity up until negative 3 halves, unioned with 9 halves up until infinity. And now, once again, what is this going to look like on our number line? Well, on our number line, when we draw this, we have, I'm just putting 0 as a reference marker once again. So Negative 3 halves is, again, negative 1.5. It'll be, somewhere around here. That's fine. Negative 1.5. We're going to include it, right? Because we're including our endpoints. It is greater than or equal to that we started with. So we're including our endpoints. And then this one being 4.5 is going to be somewhere over here. So 4.5. And we include that. And now, once again, it's all the numbers from negative infinity all the way up until negative 3 halves. So it's all this shaded region over here. And it's 9 halves to infinity. So all of this shaded region here. And once again, we see that when we have the greater than sign pointing towards the absolute value or opening towards the absolute value, we are going to neglect the middle interval. That middle interval from negative 1.5 to 4.5 makes the inequality false. However, again, it's a good thing to keep in mind if in a hypothetical world this were a less than or equal to 6, then the middle piece would be our only solution interval, right? That would be the solution and not the two outside intervals. Okay, so hopefully you guys are seeing how they now correspond, and that it's really not so bad. Okay, all right. So there's one last thing that I want to go over today, and then we should be good to go. And what I want to go over is what happens if we have an absolute value on both sides of an inequality. So the best way to do this is really to just jump in with an example. So say we had the absolute value of x plus 1 is less than 3 times the absolute value of x minus 1. Okay, well, doing this, what we have to do is we have to remember what we were doing before is we were always trying to get the absolute value on one side, right? We were always trying to isolate it. And the case is going to be no different here than trying to isolate the absolute value just like we were doing before. The only difference is that in an equation, we had the liberty to try to just keep them on their individual sides, and we kept one as positive, and then, we had two cases for whether or not the other one was positive or negative, right? We can't do that here, unfortunately. Unfortunately, what we have to do is we have to move over one absolute value to the other. So in this case, I'm going to divide both sides by the absolute value of x minus 1. So in doing so, I get the absolute value of x plus 1 divided by the absolute value of x minus 1 is less than 3, right? I moved over that multiple of absolute value of x minus 1 on the right-hand side. It's now the divisor on the left-hand side. Well, we know this certain property about absolute values going way, way back to one of the first lectures, and that's if we have the absolute value of some number over the absolute value of another number, well, it's really just the absolute value of the whole fraction, right? So what I'm going to do is I'm just going to say, okay, well, since I have an absolute value over an absolute value, I'm just going to make it one larger thing. So we have the absolute value of x plus 1 over x minus 1 is less than 3. Well, what do we know about an absolute value being less than a number? We know that we make it into a compound inequality, right? So this directly transposes into, well, we keep the number the same on the right side. We keep the signs the same. Whatever was inside my absolute value becomes my middle piece. So x plus 1 over x minus 1. And the number that we have on the right-hand side, we just put the negative version of it on the left, right? So instead of 3, now it's a negative 3 on the left, on the, the least most value. Okay, well, we're doing great, but you might be wondering, well, how do we solve this compound inequality in a compound inequality? And the answer is you don't. The answer is you split it up into the two inequalities that they are. So splitting them up, we get negative 3 is less than x plus 1 over x minus 1, and x plus 1 over x minus 1 is less than 3. So from here, what we have to do is we have to solve both of these. And the reason that I won't probably be putting these on a quiz is because this is too much work to expect for you guys when you have other questions to do. But the entire idea is we move over one absolute value to the other. We get it into a compound inequality, and then we have to solve each part of the compound inequality as two separate inequalities. So now solving the two separate inequalities, well, what we have to do is, remember, we have to solve a rational inequality using test points, right? So what I'm going to do is I'm going to add 3 to both sides, or I'm going to add 3 to both sides on the left equation. So adding 3 over here. I'm just going to solve the left one first, and then we'll move over to the right. So solving the left one, we have 0 is less than x plus 1 over x minus 1 plus 3. I need to get a common denominator. So we get 0 is less than x plus 1 over x minus 1 plus 3 times x minus 1 over x minus 1, right? My common denominator here is the x minus 1. And now, since we have common denominators, we can go ahead and add these. So we get 0 is less than x plus 1. I'm going to distribute the 3 in the same step here. So distributing the 3, we get 3x and negative 3, right? So plus 3x minus 3 all over x minus 1. And moving down with simplifying, we have 0 is less than 3x plus x gives us 4x. And we have a 1 minus 3, so we get minus 2 all over x minus 1. And what you can do if you want to make your life easy, remember how I told you guys, if you can divide out a number, do it, because it'll make your life simpler and it won't change the overall result of your solutions. And that was going way back to quadratics, right? The same idea holds here. So I see that I have a factor of 2 up on the top. So what I want to do is I just want to divide both sides by 2 just to simplify this. If you didn't do this step, you're totally okay. You could just solve the 4x minus 2 and do test points with this. But I see that I have a 4x minus 2, so I'm going to divide out a 2 from everywhere. So dividing a 2 from the left side, 0 divided by 2 is still just 0. And we are left with 2x minus 1 over x minus 1. Again, I just want to emphasize you're not wrong if you just continue to use the 4x minus 2 moving on, but I just did this to simplify. So what did we do? Well, we knew that we had test points in mind, right? Now that we have a 0 is less than 2x minus 1 and x minus 1. So what we do is we set the top and bottom equal to 0 because we need to find our numbers. So 2x minus 1 is equal to 0. X minus 1 is equal to 0. We get 2 times x is equal to 1, which means x is a half, and x is equal to 1. And now we go on our number line and we say, okay, what are we going to put? Well, we put 1, we put a half, and do we put 0, do we put open circles, closed circles? Well, we know that if we plug in 1 into the denominator, we get 1 minus 1, and that's 0 in the denominator, which means our fraction breaks, right? So that's definitely an open circle. And then we know that we also have an open circle for a half because it's 0 is less than the fraction. So we are not including when we get 0 for the fraction, right? Because if we plugged in a half, we would get 2 times a half, which is 1, and then 1 minus 1 up top is 0 up the top of the fraction. And then we would get, 0 is less than 0, and that's not correct. So now all we have left to do is we have to do test points, right? So the test point that I'm going to pick for here, and for here, I'm going to pick 2. I'm going to pick 0. And for the middle test point, well, it's not looking too great, right? We have to pick something. What I'm going to do is I'm going to pick 2/3. Feel free to pick any other fraction that's between a half and 1. I'm just picking 2/3 because why not? So we test. We have test for 0. And testing 0, we have 2x, what is it? 2x minus 1 over x minus 1. So 2x minus 1 over x minus 1. And we're plugging in 0, so we get 2 times 0 minus 1 over 0 minus 1. And this is going to be 2 times 0 is 0 minus 1 is negative 1. 0 minus 1 is also a negative 1. So we have a negative over a negative. We know that they cancel in pairs, so it's positive. And what are we looking for with this fraction? We want it to be greater than 0, right? 0 is less than this fraction. So is a positive number greater than 0? Yes, it is, right? So we know that this interval all the way up to 1/2 is going to work for us. So we can put a little plus sign because we know that that works. Okay, we do the same thing for 2/3. So 2/3. So plugging in 2/3, we know that we're going to have 2 times 2/3 minus 1 over 2/3 minus 1. Well, 2 times 2/3 is 4/3, and 1 is really 3/3, right? So you have 4/3 minus 3/3. You know you're going to get a positive number up top. Again, feel free to double check the math. I always tell you guys, if you can't see the sign immediately, just actually do the numbers and then you'll get the signs, right? So now we get 2/3 minus 3 over 3, and that's really just a negative number. So we know we get a negative number, and is a negative number greater than 0? No, right? And last but not least, we just have to test 2. So testing 2, we plug in 2, and we're going to have 2 times 2 minus 1 over 2 minus 1. 2 minus 1, we know we're going to get a positive. 2 times 2 is 4 minus 1. We get another positive, which is a positive, which is greater than 0. So hooray, great. So what I'm going to do is I'm going to put my final interval. So my final interval is, again, it's all these. And that's a plus. We know that that's a minus. So my combined interval is from negative infinity to a half and from 1 to infinity, right? So negative infinity to a half, and then, sorry, not a comma, union with 1 to infinity. Okay, this is going to be important because remember, we only did one side, right? So we're not done. We still have to do the entire other side, and then there's one last piece that we have to do. So doing the other side, we now just do the same thing, but you're going to notice that the fraction is going to be flipped, right? So instead of it being greater than 0, now we're going to try to get it to be less than 0. So we move that minus 3 over, and in the same step, I'm going to make common denominators. So minus 3 over x minus 1 over x minus 1. And this is less than 0. Well, again, common denominators, we can just add or subtract the numerators. So we get x plus 1. And now I'm just going to apply that negative 3 to both the x and to the negative 1. So minus 3x plus 3, right? Negative 3 times a negative 1 gives us a positive 3 over x minus 1 is less than 0. Okay, and let's go ahead and simplify. X minus 3x gives us a negative 2x. 1 plus 3 gives us a plus 4 over x minus 1 is less than 0. Once again, I see that I can divide 2 out on both sides, so I'm going to be dividing 2 out on both sides, and that leaves me with a negative x plus 2 over x minus 1 is less than 0. And at this point, we go ahead and we do the same process that we do with test points, just we do it twice now. We did it for the left case, and now we're doing it for the right case. So negative x plus 2 is equal to 0, x minus 1 is equal to 0. We find that we still get x is equal to 1 for the denominator, which should make sense, right? The denominator never changed. It was x minus 1 in both cases. And over here, adding x to both sides, because I don't want the negative number anymore, we get x is equal to 2. Okay. So x is equal to 2, x is equal to 1. We're going to plot those on a number line. So we get 1 here, get 2 here. And once again, they should be open circles, right? 1 for the same reason that we talked about before, the denominator problem. And 2 because, well, it's less than 0. It's not less than or equal to. So open circles. And now what we have to do is we have to go ahead and do test points for each interval. So this interval, and this interval. So I'm going to pick, let's say 3/2, which is 1.5, right? 1.5 lies between 1 and 2. I'm going to pick 0 and pick 3. Okay, so doing our test, and I'm just going to keep drawing a line here just to separate because I want to make sure that you guys understand that this is separate. So we have to test the negative x plus 2 over x minus 1. So negative x plus 2 over x minus 1, and we know that we're testing, what was it? We're going to do 0 first. So testing 0, we know that we're going to get 0 plus 2 over 0 minus 1, and this is going to be 2 over negative 1, and so that is a positive over a negative, and that gives us a negative, and is a negative less than 0, right? Again, we're looking for where it is less than 0. So is a negative less than 0? And the answer is yes. So great, this will work. So less than 0, this interval does work. We care about it, right? So this interval all the way up to 1 works. Okay, now we have to do the 3/2 interval. So testing 3/2. So we plug in 3/2 plus 2 over 3/2 minus 1. Well, 3/2 plus 2, those are both positive numbers, right? Oh, sorry, I just realized that's supposed to be a negative. I see negative x, my mistake. Either way, though, negative 3/2 plus 2 is the same thing as negative 3/2 plus 4/2, and that's still a positive number. So we get a positive up top. 3 halves minus 1, well, 3 halves is bigger than 1, so we know that we're going to get a positive number again, and positive over a positive is going to give us a positive. Is a positive less than 0? Nope. So we exclude this interval. We don't care about this one. And now we have to do one more, so we're testing 3. So we plug in -3 plus 2, because again, it's negative x, right? So -3 plus 2 over 3 minus 1. Well, we get a negative up top. We get a positive on bottom. This gives us a negative, and a negative is in fact less than 0. So hooray, this is all good, and we can go ahead and just move forward with this, and that should be it, right? So now we say that this interval is correct. This one will work for us. And we have to write out our final interval one more time. So it's all the numbers up until 1 from negative infinity, and it's all the numbers after 2 up to infinity. So we have from negative infinity to 1, union with 2 to infinity. And what I'm going to do is I'm actually going to draw my number line for both of these guys pretty similar, like pretty close together, because I want to have them overlapping. So this number line is going to be from, again, 1/2. So I put 1/2 here, and I'm going to put 1 here. And we wanted all of these numbers, not including 1/2, not including 1, and all of these numbers as well, right? And now I'm going to draw this number line, so negative infinity to 1, and then 2 to infinity right underneath it. So we have, and we're going to say that goes to 1, right? Negative infinity to 1, and then we have 2 to infinity. So if we are talking about all of these intervals, so from negative infinity to 1, not including 2 to infinity, the last thing that we have to do is we have to see where the solutions overlap. So what do I mean by that? Well, we see here that at 1/2, right, this still works, right? If I say at 1/2, if I cut here, this is working. And we see that we have a direct correspondence between the solutions working all the way up until we get to 1/2, right? But between 1/2 and 1, only one of the number lines has solutions, right? And I mean this guy in particular. If you're talking about 1/2 to 1 here, there's no solutions, right? So because we are only caring about where the solutions match, we say that we don't actually care about these guys here from 1/2 to 1. Same reasoning, we actually don't care about these numbers here because the solutions don't match up, right? Between 1 and 2 doesn't work on our second number line. And I'll just put 2 here just to keep it going, right? So there we go. So if they don't match there and they don't match there, we only can have our final solution of where the number lines match, where the intervals are both correct for both of them at the same time. So what that's going to look like for us is, well, it's going to be from negative infinity, right? It's in both cases, it's starting from negative infinity, and it goes up until we hit 1/2, right? When we hit 1/2, notice that it works for both the top and the bottom, but it stops working for the top once we hit 1/2, right? So we say, great, it stops here. And then when does it start working again for both of them? Well, it doesn't start working again for both of them up until we hit 2. And at 2, we can say, okay, great, it's working for both of them. So it starts back up again from 2 to infinity. And this is your final answer. And I know that that's a lot of work to get to a final answer. This is, again, why I would never expect to put this on a quiz. But let's go ahead and quickly recap what we did, okay? So recapping what we did here. We had the absolute value of x plus 1 is less than 3 times the absolute value of x minus 1. Well, we wanted to move the absolute values to one side, and when we did that, we condensed it into one single absolute value. We know our rule now that any absolute value of any unknown being less than a number leads to a compound inequality, right? Where we have the negative version of the number on the left and the regular positive version of that number on the right, with whatever was inside the absolute value in the middle of the compound inequality. Well, again, like we talked about, a compound inequality is really just two inequalities in one, right? It's just smushing them together. So we just expanded them into two different inequalities, and we solved for both inequalities using test points. So the normal test point method that we have, where we get 0 for one of the sides because we want to see if it's positive or negative, then we solve for both of them. We saw that for the first one, It was what was it? Negative infinity to a half, union with 1 to infinity. And then for the second one, it was negative infinity to 1, union with 2 to infinity. So we had to see where both of them agreed, and we noticed that they only agreed from negative infinity up to a half. Then they stopped agreeing up until we hit 2, and then they started agreeing again from 2 all the way to positive infinity. So we only write down the intervals where they agreed, and this would be our final solution from negative infinity to a half, union with 2 to infinity. I had originally intended to give you guys a classwork assignment on this one, but I realized that this video would be way too long if I did that. So expect at least one of these questions to be on your homeworks. If I give you 2 of them on your homeworks, we're probably not going to be able to get through both of them when we meet together, but at the very least, you should be able to know how to do this because it is going to be fairly important for you to be able to know how to handle 2 absolute values inside of an inequality. Okay? If you have any questions on this one, again, I know that because there's no classwork assignment to really reaffirm this, that this one might be a little bit confusing, but just let me know how it's going, and I will be more than happy to help you with your questions, okay? So either way, enjoy the rest of your day or night whenever you're watching this. I will talk to you next time. Try the homework. Let me know how it goes. Have a good one, guys. See you later.